Hi everybody, I hope everything's going well. I wanted to show you a video recording of this week's lab just to give you a little background, especially after doing my lab, give you some pointers on how to troubleshoot some of the things that I came across. So this week you're going to be using Logger Pro. So let me open up my classroom with Logger Pro. So for this lab you obviously need Logger Pro and your students to use Logger Pro, but let me show you really quickly that you need the following files that are very important. Actually, more important than the CMBL files is actually the video files. Motion of the cart track and acceleration due to gravity height. The motion of the cart should be constant speed, and this one is an acceleration. So those are the two motions that they're going to analyze. So what I'm going to do is I'm going to open up Logger Pro. Hold on, I have a link over here. And it should look like this. Now you could do one of two things. You could you can actually open up the Logger Pro file, which seems to be working for this. And it takes a second because it takes some time to load because it's a big file. And students seem to be downloading the file, but here's the thing, the students actually have to download the video as well in order for the file to work. So actually, I highly suggest that the students download the videos, both of the videos, the MP4 files, and then insert the file into their Word doc. So this is what it looks like, but let me show you. So if I go to Insert, and this can be just of a new file, I'm literally making this new. Go to Insert, Movie, and then what you're going to do is select the movie that that you downloaded. So in other words, for us, motion of the cart on the track. Again, it's going to take a second for it to download. Give it a second. And it should be able to import okay, and then all of the features that you would use exactly. So here we are, here's me, and exactly like that. So what you're going to do is you'll click on this button that gives you all the tools that you normally would use. So same thing, the students are going to analyze this motion, but I tell them, so if you notice, if you watch the whole video, this is on an air track. The air track is not level, so it's not going to actually go constant speed, which is fine. That's kind of the point. But if you notice, I hold it first and then push it. So the students should really start collecting data right after I push it, right? So about here-ish. And then you set the origin, and then you're going to plot it. And actually, I suggest every 4 frames, so counting 1, 2, 3, 4. Dot, 1, 2, 3, 4, and then dot, and then 1, 2, 3, 4, and then dot. Okay. So they'll do this of the whole motion forward and backward when they do this video. And then they'll go ahead and do it. So I'm just going to go ahead and do it really quick here just to make a point. So I'm literally doing this way faster and not as accurate as it should be. But you can see, like I said, I'm purposely doing this. They'll do it every 4 slides. Oh no. So here's the tricky part, because it goes backwards. See, notice it's starting to go backwards. Some students were hitting left instead of right. So make sure that they're still progressing forward, clicking this button, so that they get the backwards motion modeled here. Like that. Again. So if you look here, and just look at the X motion, right? You can see that it's going forward as a straight line and backwards as a straight line. So that's pretty cool. So they'll take this and they'll highlight this to get the slope here. And the slope here, oops, not the integral, the slope. There we go. Let's get rid of the integral. Sorry about that. And if it's going constant speed, they should relatively match. Now, notice another thing, this is good that I made this mistake. Notice that this is like 200. That's because I didn't set the scale. So I'm going to go do that now. Oops. I can get rid of data points by clicking on them with the arrow and deleting. Is make sure that they set the scale for both parts of the experiment. This is 2 meters long. So 2 meters. And you'll notice that changes my values to something more reasonable, right? To 0.43 and 0.40. So you can see that it's going faster here and slower here. So is it modeling constant speed? We'll let the students decide, but the trend line looks pretty straight, and it looks like it's more or less moving relatively in linear motion. So that's part one. They'll also they'll look at this in terms of the x velocity. And they should have both parts. So notice that there's the positive velocity here, and then it goes negative. A lot of the students don't realize, so a lot of students will actually see this, by the way, and they'll ask where did the second half go. That's because they don't have the negative part showing. So so I tell them to put like negative 0.5, and then there it is. It's on the bottom there. And that when they're getting the average, that they only highlight the straight line, not the change in velocity. So they could get the statistics of that right there, get the average velocity, which matches or pretty much matches what we saw before. And then the same thing down here. So they're going to do this and get the statistics right there. And then with the same graph, they're going to measure the integral of it. And the integral up here, because the displacement can be measured from the integral of a distance versus time graph. And again, they'll move that integral measurement up until, I'll move it up to here. This one is the positive value, and you see the negative value going backwards 0.44 and forward 0.91. So that's the general idea of the first part of the experiment. Then they're going to insert movie, and they're going to need the other movie for this, which looks like, I'll show you. We need Quinnipiac, we need Lab. And they'll actually need this video, acceleration due to gravity, the height. Once again, since this is a large video, it takes a second to do it. And there you go. And when you insert it, it allows you to use this button here. Same thing, they have to set the scale. It's also 2 meters. It's the same this is the same measurement here. And then once again, they are going to be measuring this every 4 frames. 1, 2, 3. And again, wait till I start the motion. So actually I would wait until about there to start it. So then I would actually get rid of that point and start measuring right here. So 1. And count 1, 2, 3, 4, 5, or 4. 1, 2, 3, 4. Etc. like that. So I'll show you what it's going to look like because I have the data already. So let's see. Okay. So you'll see my data from this after clicking through it. Again, it takes a little bit because it's a big file. And there you go. So after I plotted my points, you can see that nice line that I get, that nice curved line to represent acceleration. What they're going to do, they're going to highlight this and try fit and do the quadratic, because this is the delta x equals VIT plus 1/2 AT squared model. So they're going to click on the quadratic model and try fit and press OK. And they're going to record the A coefficient and multiply it by 2 because the 1/2 factor to get the acceleration. And it should match the velocity versus time graph slope. So here's the slope of that. So 0.3460 should match double of that, and I think it does. We could just double check. 2 times 0.1689, and that's pretty good, 0.3378, 0.3460. So that's what they're doing in part 2. Now, they have their lab data sheet. Another issue that they have is calculating the percent difference. Now, these are, of course, going to be positive numbers for forward motion and negative numbers for backwards motion. But when they take the average and the percent difference, they need to take the magnitude of that. So in other words, they have to ignore the negative sign here to get an accurate value for average value in percent, because we're looking at their speeds, not their directions. In fact, your percent difference will be in the hundredths if it's in the, what should I say, if you take the negative sign because it's going completely the opposite way. So those are the things that I think, most of my students had some trouble with in terms of the lab. But other than that, it seemed to be okay. They all downloaded it, they all were able to track it and make the graphs that they were supposed to here. So just verify, I'm going to send out an email with all the stuff anyway, just to make sure, but I'll send the videos again to make double sure that you have them all. You're welcome to share this video with your students if you think it's helpful as a pre-lab video, so they can figure out what areas or issues you may have. But I figured I'd show you some of these features because it's just easier to show you via video than doing a bunch of screenshots. So as always, let me know if you need anything. Best of luck with lab this week, and I'll see you all soon. Bye-bye.